Do not scroll because I'll be revealing the 40 most likely repeated questions in chemistry. Let's delve into it. Okay, the number one question here is chromatography is used to separate components of mixtures which in their rate of dash, which differ in their rate of dash. Okay, now when we talk about chromatography, right, you should know that it's one of the separation techniques, Abi, where we separate mixtures, right? Now, we can have mixtures having their spot on this chromatograph, or you understand? So there's something called the chromatograph, okay? So now this particular spot here is denoting the what? The solute. So this thing can migrate, okay? It can move. This one can also what? Can also move, okay? So now this is based on what? The rate of what? Of migration. It is based on the what? The rate of migration. So it is mixtures of different rate of what? Of migration. Okay, just like you can see in this chromatograph that you can see here. Okay, so please take note of that. So the answer to this question is what? Differ in their rate of migration. Another very important thing that you want to take note here is that one of the ways to test if a particular solute is pure is that they have a single spot. They have a single spot on a chromatograph. They have a single spot. So that shows that that particular solute is what? Is pure. Just like the way the boiling point is and all of that. So one of the ways you can also use chromatograph to determine if a particular solution or solute is pure. All right. So that is that. So the answer to this question is different in their rate of migration. Okay. Number two, the addition of water to calcium oxide leads to dash. The addition of water to calcium oxide leads to that. Very quickly, you want to know that calcium oxide is called what? Is quick. Is what? Quicklime. Okay. Another question that you must know is that calcium oxide is used to dry ammonia. That's another JAMB question. Calcium oxide is used to dry ammonia. So when this guy reacts with water, he's going to form what we call what? CaOH into 2. Okay, so this is calcium hydroxide. Calcium hydroxide. When this guy reacts with water, he's going to form calcium hydroxide, which can be which can be solid. Okay, now when that solid now dissolves in water, okay, it will now form what we call slake lime. Okay, it's now called slake lime. So the solid here cannot dissolve in water and now become OH into bracket what? Aqueous. This will be 2 aqueous. So this is what we call what? Slake lime. So take note of that. So this is actually a chemical change because new product is being formed. It is what? It is a chemical change. So the answer to this question is what? Chemical change. It's not a physical change, right? I mean, it's not a physical change. What are the examples of physical change? You know, when we convert liquid to solid to maybe like liquid to solid or solid back to liquid, then that liquid back to gas in form of vapor. So that is, you know, a form of physical change because it is reversible, just as you can see. So, but this one is forming this and is a what? It is a chemical change. All right. Now another thing, the third question here is which of the substance is dash? Which of the substance is dash? Now, as you can see, which of the substance is a what? Is a mixture. Which of the following substance is a mixture? The number one is sulfur powder. Absolutely. This is an element. Sulfur. Just try to say that is an element. Okay. Number two is bronze. Right? Now, you should know that bronze is an alloy. Bronze is an alloy which contains what? Which contains copper and what? And tin. Bronze is an alloy that contains copper and tin. Please take note of that. And you should know that alloy must be a mixture. Absolutely. They are not chemically combined. So alloy, this is an alloy. Hence, it is a mixture. Okay. Now, yeah, distilled water. Absolutely. They are just trying to say H2O, which is a compound. So the answer to this question is bronze. Now, the sister of bronze is brass. 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 That means this is copper and zinc. So JAMB question is, what is the major difference between, or what is similar between brass and bronze? They are both alloy, but this one has copper here, and bronze also has what? Copper. So the only difference is that brass, that means zinc. So this is zinc. Why this one is what? Tin. Bronze. O-N. Tin. Okay. So the answer to this question is what? Is bronze. Now, number 4. Sieving is a technique used to separate mixture containing solid of dash. Sieving, I'm very sure you guys have sieve at home, okay? So you realize that if you have beans and rice, right? Mom will ask you, okay, go and sieve that so that the rice will move with sieve, then the beans, which is larger, will be on top. So if they are of different sizes, that's when you're able to sieve. But if they are of different sizes, the rice and beans will just move down. So the major thing, the major property in sieving is what? Is different sizes. If they are of the same sizes, you can't sieve them. If they are of larger sizes, it means they are still the same. They are just of larger sizes. Smaller sizes still mean they are still the same. So the only thing you can sieve is that they are of different sizes. That's when your gari and your rice mix together, the gari can move down because they are of different sizes. So the answer to this question is what? Different sizes. Okay. Number 5. The presence of impurity in a substance will cause the melting point to dash. Impurities to a particular substance will cause the melting point to dash. Now, I will teach you 2 ways. There can be an effect of impurities to a boiling point. There can also be an effect of impurities to a what? To a melting point. They are 2 different things. Now, if you remember in your at home when you are cooking, your mom will ask you, go and add salt to that water. Now, you only understand chemistry actually. It's just trying to say that when you add salt to water, the boiling point will increase. But when you add an impurity to a solid, the melting point will reduce. So for melting point, the answer is reduce. But if they change this thing to what? To boiling point. To boiling point. The answer will be what? Increase. So impurities will increase the boiling point of a substance. It will increase the boiling point of a substance, but it will reduce the melting point of a substance. Please take note of that differences. It is very, very important. Okay. Now, number 6 here. Which of the following is a measure of average kinetic energy? Which of the following is a measure of average kinetic energy? Well, if you are new here, I'm going to be uploading most likely questions in biology, physics, and chemistry. I want you to hit the subscription button, comment, and you like this post, okay? Now, the average kinetic energy here, okay? Now, there are 2 different things you have to understand. It can be a measure of total internal energy, and it can be a measure of average kinetic energy. Now, when they ask you, the measure of average kinetic energy here is temperature. Is temperature. I mean, at home, you can actually experience this when you are cooking and your mom will ask you, increase the temperature so that the motion, the kinetic energy of the molecules will increase. So the higher the temperature, the higher the kinetic energy. I don't want to go deep because there are actually a lot of concepts as regards this, but when you resume 100 level, we'll talk about it. But for now, just know that the measure of average kinetic energy, the answer is temperature. But if they change this to measure of total internal energy, that is heat. If it is total internal energy, that is heat. But if it is average kinetic energy, the answer is what? Is temperature. Now, the last question here, number 7. 60 centimeter cube of hydrogen are packed with 20 centimeter cube of oxygen at 100 degrees Celsius. This is the most important thing here. At 100 degrees Celsius, the total volume of residual gases is dash. The total volume of residual gases is dash. Now, this is very, very important because you have to understand the concept of Gay-Lussac's law to be able to explain this very well. Okay, now imagine we have the reaction like this, where hydrogen reacts with oxygen to form water. Now, why this 100 degrees Celsius is important is that if it is not forming steam, if it is not steam, it will be liquid, right? And don't forget, Gay-Lussac's law is trying to say when gases combine, underline, when gases combine, they do so in volume and bear a simple whole number ratio. Very, very important. Now, that's why they have to put this 100 degrees Celsius here. To tell you that the water form here is actually a steam. It's a steam that is in gaseous state. Now, hydrogen, we already know that it's going to be in gaseous state. Then this one is also gaseous state. Now, if you balance this equation, I know you are familiar with this kind of equation. It will just be 2 will be here, then 2 will be here. That means the number of hydrogen atoms here is 4. Number of hydrogen atoms here is 4. Oxygen atoms here is 2. right? And the molecule is 1. The number of oxygen atom here is also 2. That means the ratio is what? 2:1:2. They bear a simple whole number ratio. Now, let's say the JAMB question, they ask you, and they didn't put 100 degrees Celsius here. They didn't show that the water form is a form of steam. Then it will be 0. That means this water here will be liquid. Abi? And pressure don't affect liquid. They don't affect solid. Pressure only affects gases. Okay? So that is why this is so important. That's why this 100 degrees Celsius is so important. Now, they now give a question. 60 centimeter cube of hydrogen. Now, they gave 60 here. Right? And they gave 20 centimeter cube of oxygen. Now, people don't understand this question. But I'm going to explain and you will get it once and for all. Now, look at what I will do. Look at what I will do. Now, if the ratio is 2:1, there are 2 ways I can do it. I can start from here. If this is 60, that means this should be what? Half, like 2:1. If this is 60, this should be 30, right? That is one way. I can also go like this. If this is 20 and it is 1:2, that means this will be 40. That is the 2 ways I can go. But the first one is wrong. Let me tell you. If this is 60 and you told me that this will be 30, where am I going to get the remaining 10? And because they only gave me 20, that means I'm using more than what they gave me, which is wrong. So I'm going to nullify this method of going from here to here. But I can go, you get that, right? Because this is 20 and I'm using 60, that is wrong. So the only way I can go that will make sense is that, if this is 20, I can say what I will be using here, what I will need is what? Is 40. This just explains the concept of excess and limiting reagents. Because this shows that this one is in excess and I don't care. You can give me something in excess. I just have to get what I need. But you cannot give me something and it will not be here. So eventually, that means if 40 cm cube react with 20 cm cube, right? This has reacted. Then this, because it is 2:1:2, that means this is 40 and this is 20 because it is 1. That means automatically this will be what? 40 cm cube. Just like to say 2:1:2, 2:1. But don't forget, after reaction, what happens? I've only used 40 cm cube of 60. That means I'm left with what? I'm left with 20 cm cube. Right? I've used the whole of this guy because it is the 20 that they gave me that I need for this reaction. That means nothing will be here. But the last thing, this is formation. I'm not using, these are the reactants. You use up reactants. You form the product. Right? So this, because I'm forming this, eventually this will be what? 40 cm cube. So what they call by total volume of residual gas means what is left. Absolutely. I'm done with the whole of 20 cm cube I was given. That means 20 is left from the reactant side. Then 40 will be left because it's a formation. I'm forming it. I did not use it up. Okay. So the total volume of residual gas is what? 20 plus 40, which is what? 60 cm cube. So the answer to this question is A, 60 cm cube. Please, what is important is that you take note that it is forming steam, 100 degrees Celsius, which at the temperature at which water boils, right? That is the boiling point of water. Number 8, helium is often used in observation balloons because it is dash. Helium is often used in observation balloon because it is dash. Now, what you have to understand is that helium after hydrogen is light too, right? Hydrogen is the lightest known element, right? Now, helium has an atomic number of what? Of 2. Why hydrogen has an atomic number of what? Of 1. Which means after hydrogen, it is helium. Now, it is used in this for this purpose because it is light, 1, but it is non-combustible. Unlike hydrogen that is highly combustible. You understand? So the answer to this question is because it is what? It is light. It is light and non-combustible. Unlike hydrogen that is easily combustible. Okay, so that's why we prefer to use what? Helium. Number 9, sorry. Phosphorus is stored underwater to prevent it from dash. Now, phosphorus has what we call the low ignition temperature. Okay, so if you just leave phosphorus alone, it can easily catch fire. So the reason why it must be stored underwater is because it's to prevent it from what? From catching fire. To prevent it from catching fire. Okay, that is the reason why phosphorus is stored under water. Okay, take note of that. The same thing, you have to also know that ethyne is also stored under propanol. Okay, because same thing is it can easily just explode because of its high explosive nature. Ethyne, another JAMB question. Ethyne is stored under what? Propanol. Okay, take note of that. Number 10. It can be protected, iron can be protected from corrosion to take place by coating the surface with dash. Now, one thing you have to know here is that you have to know what we call electrochemical series, okay, which we talk about the order of electropositivity series and electronegativity series, okay. You should know that iron is somewhere around the middle, right? Now, look at this. Silver is below iron. Gold is, in fact, is the least, is the last. Zinc is above iron, while copper is below iron. Okay, if I want to just let you know, you should know that potassium, sodium, Abi, Mg, Al, this is where iron is. So, can you see, the only thing that is above iron is zinc, aluminium, magnesium, calcium, sodium, and potassium. So, these things can be used to coat iron to prevent this from corroding. Okay, don't forget, iron does not actually corrode. The corrosion of iron is called what? Rusting. So it's a special form of corrosion for iron. Just take note of that, okay? But that is not what they are testing here. I know that you should know what rust is. Rust is a compound, Fe2O3 dot 2xH2O. So this is rust. And I think I already explained also that this rusting can only take place in the presence of two things, air and water. Rusting can only take place in the presence of two things, air and water. Okay, please take note of that. It's a JAMB question. So from this question, the answer is what? Zinc. Because zinc is above iron. Now, the 12th question here, the pollutant that contributes to depletion of ozone layer is dash. You must know this one. Of course, you know what ozone is. O3, Abi, that is ozone. O3. Now, there's something called CFCs. We call them, let me clean this. We call them chlorofluorocarbons. Okay, chlorofluorocarbons, they have the ability to deplete ozone layer by reacting with what? Ozone. Okay, so it is this pollutant, chlorofluorocarbons, CFCs. Chlorofluorocarbons. Okay, now number 13. The product of combustion of candle wax are dash. Please note, anytime an organic compound undergo complete combustion, it gives CO2 and water. But if it is a partial combustion, it gives what? CO and water. That is carbon dioxide and water if it is partial. But if it is complete, it's going to give CO2 and water. Take note of that, okay? This is an organic compound, candle wax. So if it undergo combustion here, they didn't say complete or partial. They are trying to say it is complete. So in this case, it will be what? CO2 and water. Okay? Now, number 14. The noble gas with high force penetration used in aerodrome beacon is what? Is neon light. Neon light has that penetration, right? And it can be used in what? In aerodrome beacon. So the answer to this question is neon. Neon is the noble gas used for that purpose. Okay, take note of that. Don't forget that helium is the most abundant noble gas in the universe. Why argon, Ar, like Ar, is the most abundant noble gas in the atmosphere. Take note of that. So the answer to this question is neon. Now here, a consequence of global warming is dash. You must never forget this. Especially in a place full of ice. Okay, that glacial area. So when there is global warming, that global effect, that heating effect from the sun on the Earth's surface, we allow that ice block to melt. And the consequences is what? Flooding. The consequences is what? Is flooding. You must never forget this. It's flooding. It's a common JAMB question. Okay, flooding. The freezing point of water at 760 millimeter of mercury is dash. Don't forget, this is what they call the standard pressure. So those are the standard temperature and pressure. So at standard temperature and pressure, the freezing point of water is what? Is 0 degrees Celsius. Or I can convert it to Kelvin by adding 273. So this becomes 273 Kelvin. So if you don't see 273 Kelvin, the correspondent is what? 0 degrees Celsius. That is the freezing point. If I now ask you the boiling point, it will be what? 100 degrees Celsius. Or by adding 273 to it, you also form what? 373 Kelvin as the what? As the boiling point of water at this pressure, which is standard. Okay? Now, number 17. The lightest known element, I even explain it here. It is lighter than helium, but it cannot be used in observation of what? Of balloons, because it is combustible, but it's still the lightest. So the answer is what? Hydrogen. Hydrogen. Okay, now number 18. The anode of lead acid accumulator is dash. The anode of lead acid accumulator is dash. The anode, now, I know most of you don't know this, but you will know it now. The anode is dash. Now, to know that, you must understand a mnemonic is called Leclanche. Leclanche. What does it mean? A here means accumulator, right? Which is lead acid accumulator. Now, this thing will be together. So it becomes lead oxide. What is here? Cathode. And this thing together, lead, what is this? A lead anode. That means the electrolyte is what? H, which is what? H2SO4. So for lead acid accumulator, the anode is what? Is lead. Can you see? Lead, once you know these mnemonics, Leclanche. So for accumulator, lead acid accumulator, lead oxide C, cathode, and lead anode. Then the H is for what? H2SO4. We've started our intensive marathon class, okay, where I myself and my other experienced colleagues, the person like, Nurse Bright and the likes, Isaac Adeniro and my other quiz Ben, will be coming to teach you for good 7 days, where we'll be destroying all your JAMB syllabus. So if you want to join, you'll see my number around this video anywhere, so you can reach out to us and you can register. Okay, registration ends on the 15th and the class starts from 17th to 23rd. If you have not read anything, this is the best time for you to join. We'll be destroying all your JAMB syllabus from A to Z: physics, chemistry, biology, English, and math. So send a DM now to join. Okay, if you enjoyed this, make sure you follow us and make sure you subscribe to this channel. Okay, now, just like I said, that means the answer to this question, the anode of lead acid accumulator is what? Is lead. If I now ask you what is the cathode, it is what? Lead oxide. What is the electrolyte? It is H2SO4. Now, Daniel cell, the cathode of Daniel cell and the anode of Daniel cell. Now, you must know that. How do you know that? Let me show you too. Okay, to know that there's a mnemonic, which is what? Daniel cousin, length camphor zinger. Daniel cousin length camphor zinger. Daniel cousin, I think it's not showing well. Let me make it. Daniel cousin length camphor zinger. Okay, from these mnemonics, you'll be able to know the anode and cathode of both Daniel cell and Leclanche, and you will not have to cram it. Okay, Daniel means Daniel cell. Cousin means copper and zinc. Cousin means copper and zinc. Length means what? Leclanche. Right? Leclanche. And this camphor resemble carbon, and this zinga resemble zinc. Now, so what does it mean? The C is for cathode. No pressure, okay? C is for cathode. So what does it mean? For Daniel cell, the cathode is copper, the anode is zinc. For Leclanche cell, these two are examples of primary cell. You must take note of that. For Leclanche cell, the cathode, which is C, is carbon, the anode is zinc, which means the anode of the two cells is both what? Is zinc. You must take note of that. Okay? So now, the answer to this question, the cathode of a Daniel cell is what? What is the cathode of a Daniel cell? Copper. Copper. Now, what is the anode of a Daniel cell? The anode is what? Is zinc. Okay? Very easy. So, let's get to question 20. Question 21. We are asked to write the equilibrium constant for this particular reaction. Okay? How we go about it? Ideally, if they give you a question like this, and you're asked to write equilibrium constant, the state of matter must be given. But in this is directly from JAMB question. Okay? Now, this is not given. So, they are just asking you to write a normal equilibrium constant. So, they are not asking you that you should write for Kp or write for Kc. So, they're just being plain. So, you just treat it as a normal reactant. Okay? So, in this case, what they expect you to do is that, now don't forget that when you're writing K for any reaction, it is always the product over what? Over the reactant. Okay? The concentration of each of these products over the concentration of the reactant. Now, because the state is not given in this case, okay? So it will just be K equals to G raised to power the coefficient here, which is P, dot, please take note, it is not plus, it is either multiplication. And that multiplication, you can denote it with a dot, or like this, or without anything. Okay? So multiply by what? The concentration of H raised to power Q all over E raised to power what? M dot N raised to power F. So this is the answer to this question. So when you ask to write equilibrium constant for this particular reaction, for a reaction like this is what you just write. Because there are cases where they will ask you, maybe the state of this one is solid, the state of this one is liquid, the state of this one is gas, and the state of this one is aqueous. I already made a video on that. You can check around this my YouTube channel to check video on that. But just note that we don't write equilibrium constant for what? For solid and liquid. It is only gaseous and aqueous species. Those are the two things we write equilibrium constant for. I already made a video on that. That's the answer to this. Now, the percentage of calcium in CaCO3. Calcium in CaCO3. Now, you have to understand something like this, percentage composition, okay? Now, the only way to go about it is that it's just Ca over CaCO3 times 100%. Okay? Very easy. That means you must know the atomic mass of each of these guys. So if you know the atomic mass of calcium, which is said to be what? 40 over 40 plus 12. Now, this is 3 oxygen. I mean, this is CaCO3. 3 into what? Into 16. Okay? Now, from here, you can say that this is 40 all over 52 plus 48. This is 100 times 100%. So 100 will go with this, then this is what? 40%. So the answer to this question is what? 40%. It's just you showing calcium over the summation of the molecular mass of this guy, which is calcium plus carbon plus 3 oxygen. Okay, so the answer to this question is very easy. So let me give you a question. So let me ask you, calculate the percentage of sulfur in SO2. So drop the answer in the comment section. The percentage of sulfur in SO2. What will you do? That's sulfur over SO2 times what? 100%. So I'll be checking the comment section to see who got it. Okay, that is that. Now, how many bond pairs are present in water? Now, this question is so easy. Now, you have to realize that I will not go far with this. You have to realize that when you have oxygen being the central atom of water, you have hydrogen to this side, then hydrogen to this side. Okay. Now, each stroke contains 2 electrons. One from oxygen, another one from hydrogen. One from oxygen, another one from hydrogen. Okay. So these are the bond pair. That means the answer to this question is what? Is 2. Very easy. But JAMB can twist it and ask you how many lone pair has water. Or how many lone pair does water has? Okay, you must know that there's a pair here and there's another pair of electron here. So this is a lone because it's not bonded to anything. It's called a lone pair. This is also a lone. It's not bonded to anything. It's called another lone pair. So water has two lone pairs of electron and it also has two bond pair of electron. You understand? So the answer to this question is 2. But if JAMB now twisted, how many lone pair? This is a lone pair 1. This is another lone pair 2. Okay. So that, like, let me just say 1. So 1 plus 1 is what? 2 lone pair. So that is, but the answer to this question is 2. If they are not twisted, how many lone pair is also 2. Okay. Now, basicity of an acid. Basicity of CH3COO3H. Now, this is what we call ethanoic acid. Okay. Now, note that yes, there can be a lot of hydrogen here. Look at it. H3, then H. That's 4 hydrogen. But not all the hydrogen atoms are replaceable, right? Because basicity of an acid, we are talking about the maximum number of replaceable hydrogen ion, or sometimes they call it hydrozonium ion, present in 1 mole of the acid. Now, in this acid, yes, there are 4 H, right? But it is only this guy that is replaceable. So the basicity of ethanoic acid is 1. So if JAMB asks you, what is the basicity of H2SO4? Yes, the O2 here is replaceable. So the basicity of H2SO4 is 2. What is the basicity of HCl? Yes, the whole H here is replaceable. So the basicity is 1. Let's say, what is the basicity of H3PO4? The whole H here is replaceable. Hence, the basicity is what? 3. But this guy, yes, there can be a lot of hydrogen, but the only one that is replaceable is 1. So that's why this is the answer. Okay, the color of litmus paper in alkaline medium. Okay, I'll be using this to explain quite a lot of things, so I want you to pay attention. Now, when they say alkaline medium, what is the color? You have to know this thing. Okay, now the way I use, you have to know is, these are what we call indicators. Indicators, okay, I want to be sure if you can see that. Okay, let me start here. Now, indicators. Now, alkaline, if it's not alkaline, you will see what we call basic. Then you see acidic. Then you see what? Neutral. Now, what are the major indicators? The major indicators, they are not limited to these 3. Is what? Is your last menstrual period. Your last menstrual period. What does last menstrual period mean? It means litmus paper, right? This menstrual is what? Is methyl orange. This is small. Is methyl orange. Is what? Methyl orange. Then this period means what? Phenolphthalein. So these are the 3 major indicators. Litmus paper, methyl orange, phenolphthalein. Okay. Now, what does, in basic medium, what will be the color? You know, when you are having your menstrual period, what will you say? Bring your pad. So when you have, so you should bring, well, this is small. Let me just clean this. So we say bring your pad. Okay, what does bring your pad means? That means litmus paper in basic medium will be B, which is blue. Methyl orange in basic medium will be Y, which is yellow. Okay, the period here, which is phenolphthalein, here it is pink, not purple. It is pink. Okay, now in acidic medium, it will be what? It will be R square C. R square C. What does it mean? RRC. So which means in acidic medium, litmus paper is what? Is red. Methyl orange in acidic medium is also what? Is also red. Phenolphthalein in acidic medium is what? Is colorless. Is colorless, okay? Is colorless. Now the last part which is what? Is neutral. The last part, which is neutral, is pork. Pork. What does pork mean? This means purple. This means orange. And this means what? Colorless. I'll give you another question. So now let's answer. So what does it mean? Last menstrual period, which means litmus, methyl orange, and phenolphthalein. Bring your pad. I mean, at your last menstrual period, you bring your pad, which means blue, yellow, and pink. Then R square C, which means red and colorless. Then pork, which means purple. That is, litmus is purple at end point or neutral. Methyl orange is what? Orange at end point. Then phenolphthalein is colorless at end point. So now let's answer this question. Okay. Now the question says litmus, color of litmus in alkaline. This is alkaline. That means color of litmus is what? Is blue. Is blue. That's the answer. The color of phenolphthalein in alkaline. This is alkaline. What is the color of phenolphthalein? This phenolphthalein is pink. The color of phenolphthalein is pink. Now, there's a JAMB question that they ask, which indicator will pose a problem when, in the laboratory? Is phenolphthalein. Is phenolphthalein. Look at it. When it is at the end point, it's colorless. When it is at acidic medium, it's colorless. You don't know which one is which. Like, are you in acidic medium or you're at end point? Because you're actually colorless at both ends. So that's the problem. So it is another question is that which indicator pose a problem in the laboratory? Is phenolphthalein, because it is colorless and colorless. You don't know when it is in acidic medium or when it is in basic medium. So take note of that. So the next question is, what is the pH of 0.001 molar ACl? Very easy. I already taught you. We already know that pH is minus logarithm to base 10 the concentration of H plus. I already taught you this. There's a video on how to calculate pH without calculator. This is a no-brainer, okay? You want to check it out in my video. Just subscribe and check it out in my video. I have a video on how to calculate pH without calculator. And if you want to join our marathon class, it's going to be starting on the 17th to 23rd, and registration ends on the 15th. You should send, my number will be displayed around this video. Send a DM to us. We are going to destroy all your JAMB syllabus, okay? We'll distribute them into 7 days. Physics, chemistry, biology, math, and English. If you have not read anything or you want to start from afresh, this is the best place to be, and I'll be discussing with my other 15 medical colleagues across Nigeria. I will be teaching you live and direct, okay? So you want to be part of this, send a DM to me on WhatsApp, and you'll see my number around this video, okay? Now let's continue. Now, this is the question. Now, the pH of 0.001 molar ACl. Now, because this guy is 1, that means the H plus will be equal to this. So the H plus, the concentration of H plus will be what? 0.001 molar. I already taught you how to convert this. Okay, if you don't know it, look at it. Just note, this is what? Point. And this is 1. It will be 1 over, take this as 1, 1, 2, 3, 1, 2, 3, which is what? 1 over 10 raised power 3. Now, because it's 1 over 10 raised power 3, that is what? 10 raised power minus 3. So from here, I can substitute this into this, right? Very easy. I will just say pH equals to minus log to base 10, 10 raised power what? Minus 3. Don't solve anything. I repeat, don't solve anything. Immediately you have this like this, don't do anything. What is the answer? The answer is pH equals to, what is here? 3 minus, this actually means 1 times 10 raised power minus 3. So just pick what is here. 3 minus log what is here, which is 1. So that means, and you know that log 1 is what? Is 0. That's why 3 minus 0, which is what? 3. Now, let me say I have something like this. You might think this is fluke. Let's say I give you something like pH equals to minus log to base 10. Let's say 2 times 10 raised power minus 4. Don't solve anything. The answer is 4 minus log, what is here? Log 2. Go and press it in your calculator. You see that it's correct. And I already know log 2. I've made a video on how to know log 2. Log 1 to log 10 without calculator. Me, I already know log 2 because I made the video. So it's 0.3. That's log 2. So the answer to this is 3.7. Yeah, press your calculator and check. So based on this that I taught you, you solve this. Let me make this one 3. And let me make this one 5. So tell me the answer in the comment section. As you are solving it, just be dropping like that. Okay. Now the next question is, ethanoic acid is dash. Is it monobasic? Is it dibasic? Is it tribasic? Okay. Now, this is very easy. This is very easy, okay? Now, when they say ethanoic acid, this is what they mean. CH3COOH, okay? Now, this is the basic here. So it is monobasic. But let's say I ask you, it's a 1,2-dioic acid. Something like this. This is what they call ethane 1,2-dioic acid. So in this case, this is what? This is dibasic. But because this one is just 1, so this one is monobasic. Okay. So the answer to this question is what? This one is 3, right? Why this one is what? Monobasic. Now, NO2 is called dash anhydride. You must never forget this kind of question. NO2 is called mixed anhydride. NO2 is called what? Mixed anhydride. Because NO2 can react with water to form 2 acids. Never forget this equation. HNO3, HNO3 plus HNO2. Never forget this equation. So it's because it formed 2 acids. It formed HNO3 and HNO2. HNO3 and HNO2. Because of that, it's called mixed anhydride. Okay? So the answer to this question is what? Mixed anhydride. Now, the last question, question 30. Which is acidic oxide? CO2 and zinc oxide. You must note that there are basically 4 amphoteric oxide. And we use ZOLT to remember. That means zinc oxide is an amphoteric oxide. Aluminum oxide is an amphoteric oxide. Lead oxide is an amphoteric oxide. And tin oxide is an amphoteric oxide. So this one is out. What is an amphoteric oxide? They are oxide that can react with an acid or base to form salt and water. They can react with both acid and base. When they say amphiprotic, the word amphi means 2 doers. That's why amphibians can stay on land, damp area, and aquatic area. So they are amphi, 2 doers. Okay. So that's that. Zinc oxide is even out of it. Why would this be an acidic oxide? Is that it can react with water. That is, CO2 can react with water to form an acid. So hence is an acidic oxide. So the answer to this thing is what? CO. Question 31. When ammonia and hydrogen bond together to form ammonium ion, the bond is called dash. Okay. In fact, I just uploaded a video on chemical bonding. Everything you need to know about chemical bonding, from types of chemical bonding, electrovalent bond, covalent bond, types of covalent bond, single bond, double bond, triple bond, dative or coordinate covalent bond, hydrogen bond, van der Waals bond, London dispersion forces. I did not dwell on that because JAMB will not really dwell on that. So just basic stuff. I just explained. So check my YouTube here and you'll see the link to that or the video itself. Okay, you can also check my live. I think I made the live video on it. So just check. So now, but then let's go. Ammonia and hydrogen bond together to form dash. Now, they should have said ammonia and hydrogen ion. It's not because it's not hydrogen that is bonding with ammonia, it's the ion. Because of this. Now, what does it mean? Is that when ammonia bonds with H+, don't forget that this H+ is called a proton. Why do we call it a proton? Don't forget that hydrogen here is 1. So when hydrogen loses an electron, it becomes H+. So when this guy now forms NH4+, okay, then we call this type of bond, we call it what? Coordinates, or what we call dative covalent bond. Covalent bond. You must know this. It's not only this guy. You can see it in H3O+. Okay, that is that. The 3-dimensional shape of methane is dash. You must know this one. Never forget. Is what? Is tetrahedral in shape. Don't forget that methane is what? CH4. And when you draw CH4, it's like this. The way we should actually draw it, this is the way we should draw it. But it's because of convenience's sake. It should be H, 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 H. So that you can see that tetrahedral shape. This is the actual way to draw methane. But because of convenience's sake, that's why we used to do like this. It's because this is the way it should be. So the answer to the question is what? Tetrahedral. The shape of ammonia is what? Is triagonal pyramidal. Trigonal what? Pyramidal. And don't forget that ammonia is also what? sp3. Never forget that. And the bond angle is what? 107. The bond angle is 107 degree. Never forget that. The shape of water, absolutely. I'm very sure you are familiar with that. The shape of water is either V shape, bent shape, or what? Angular. Some people call it so, depending on the option. So bent shape. Okay, now question 35. Okay, now the hybridization and bond angle of methane is dash. The hybridization and bond angle of methane is dash. Please, if you listen to this point and you've not subscribed, please do so right now. Subscribe to this channel, drop a comment, share to your friends, because I'll be dropping series of 40 likely repeated questions in physics, biology, and chemistry. So you don't want to miss it. You have to subscribe now. Hope you have subscribed. They have to do so. They have comments, okay? Thank you so much, okay? I'll be helping you to score really high in your JAMB, at least 300 plus. And if you want to really do so well, you can also join our marathon class that is starting April 7th to April 23rd, okay? So you send a DM to join. We have dissected all your syllabus into 7 days, 8 hours daily preparation, and 2 hours for each subject, okay? So you want to send a DM to join. Now, the hybridization and bond angle of methane is dash. Please note that methane is also sp3. In fact, you must know, because the common JAMB question. Alkane is sp3. Alkene is sp2. Alkyne is sp. That is the single bond, the double bond, and the triple bond. You must take note of that. Now, that's so it is what? sp3. Now, what is the bond angle? It is 109.5 degree. That's the bond angle. Now, what intermolecular force is in water molecules? Look at the word. Water molecules. Not water molecule. H2. H2O is water molecule. But many H2O is called water molecules. Okay? Now, what does it mean? Look at it. In H2O alone, the bond here is covalent. Is covalent. But when you have H2O together, where you have something like this, O combined with H, this combined with O, then H, this combined with O, then H, this combined with O, then H. This kind of intermolecular forces is called what? Hydrogen bonding. The intermolecular forces in water molecules, not water molecule, is called what? Hydrogen bonding. Hydrogen bonding. Hydrogen bond. In fact, you must know that there are majorly two types: the van der Waals force and the hydrogen bond. In fact, hydrogen bond is stronger. It's a stronger bond than van der Waals. Okay, they are both intermolecular forces, but it's a stronger one. Now, because I think there's a question on that. The shape of CO2 is dash. Please note, the shape of CO2 is linear. The shape of CO2 is linear. How? Look at the way it is. This is it will combine with oxygen, then it will combine with oxygen. I already taught you that a stroke means 2 bonds. Another stroke means 2 bonds. This means 2 bonds. This means 2 bonds. Okay, that's the idea. So this thing you are seeing here, you see, there's no way you want to draw this. It will still be what? The bond angle will still be what? 180 degrees, like angle in a straight line. So the shape is what? Linear. Okay? Now, what bond is in sodium chloride? The bond in sodium chloride, of course, is what? Ionic or electrovalent bond. It's the strongest bond, right? It has high melting and boiling point, okay? So it exists between a metal and a non-metal, which involves transfer of electrons. So this one is ionic, okay? Ionic bond. Ionic. Now, the bond, okay, the bond of ethene, okay, is it the bond? Yeah, the bond in ethene, yes. The bond in ethene is dash. Please take note. All organic compound, the bond, the chemical bonding in them is what? Is covalent bonding. Covalent bonding. Covalent bonding. I already made a video on chemical bonding. So you want to check my live, just go to the live session of this part. When you are done, you'll see a comprehensive video on chemical bonding. I explain everything you need to know. Everything. If you don't get it after you watch it, Message me. I have something for you. You're going to get it. So the bond in carbon dioxide molecules. Molecules. You know, it's not molecule. If it's carbon dioxide molecule like this, CO2 alone, it will be what? Covalent. But in carbon dioxide molecule is van der Waals forces. That's the bond. Now, why is this water hydrogen bond? You must know. How do you know? That when hydrogen bond with, F, when hydrogen bond with O, when hydrogen bond with what? N, the bond that must be formed is what? Hydrogen bonding. How do I know it? I just use the word fun. Fun. What does fun means? F for fluorine, O for oxygen, then N for nitrogen. So when you have hydrogen to F, hydrogen to oxygen, hydrogen to nitrogen, then it is what? Hydrogen bonding in that molecules. But look at the CO2. There's nothing like hydrogen to anything. It's just CO2 molecules. That's van der Waals. If I say what is the bond in iodine molecules, van der Waals. What is the bond in hydrogen molecules? Is van der Waals. Okay? And it's a weaker form of intermolecular force. At this point, I hope I've been able to help you to achieve this first 40 likely repeated question in chemistry. If you enjoyed this, make sure you comment. If you want me to do more, also tell me to do more, and I will do this for you, okay? Tell me to do more, subscribe to my channel, and share this to your friends. And lastly, comment, follow me, subscribe, and I will see you in my next video, okay? And if you want to join our class, our marathon class that is going to start April 17th to April 23rd, the registration ends April 15th. You can send me a DM. It's one of the best things you want to see, where I will teach you 8 hours every day, okay? 2 hours for each subject, and we've already arranged. I think I will display it around this place where you can see the topics, okay? We've distributed all the topics into 7 days, and we'll be just taking it one after the other for the next 7 days, April 17th to April 23. Early bird registration ends April 15th. Deechemistrytutor here. See you in my next video. Bye for now.